Hey everybody, so thanks for the introduction. I'm a software engineer at Norton. I have about 4 years of experience there. And actually at that place of work, I had the opportunity to start from day zero on a project, which is about building AWS Lambda. So basically building microservices on AWS Cloud powered by Lambda. So I'm going to talk about that experience today and some of the challenges. Also, how we got from zero to production is a main theme of this. So let's dive right in. So actually, this is what I imagine the AWS Cloud is according to Amazon, if you ask them. Lambda is kind of like a crown jewel of that, really powerful tool. And this is the abstracted layer of it. This is what it looks like from the clouds. But I want to dive into the nitty-gritty details and explain what it is. So what is AWS Lambda? If you're not familiar, it's basically just a VM in the cloud. So Lambda function is a function that you deploy your code to, and you can run that code in incremental doses. So Lambda service is mostly about like simple use cases, even though you can have complex applications on there. It's generally going to be processing data or making API calls and things that are just generally running for a short amount of time. And the max time you can actually run a Lambda on a single invocation is 15 minutes. Another really cool thing about Lambda is the Lambda service handles auto-scaling for you. So that's basically the load balancing and auto-scaling. And it's really powerful. You just write your code, and after you deploy it to Lambda, you don't have to worry about any of the server management or auto-scaling. So in this presentation, I'm going to go over an event-driven architecture, which is a really good use case for Lambda. I'm going to explain what that is. I'm going to explain how Lambda is actually part of a much bigger ecosystem in AWS than just using Lambda. I'm going to go over some edge cases that my team encountered when we were working with Lambda and deploying those to the cloud. And finally, I'm going to talk a little bit about the CI/CD pipeline, which is a core component of actually pushing to production. So how do you actually invoke a Lambda? Once you have your code up in the cloud, how do you start it and make it do something? And here are a couple of common patterns for how we do that. You could invoke it via API gateway, and in this scenario, it's going to act a lot like a REST API. And this is known as synchronous execution, because when you invoke it, you're going to get a response back from the Lambda, and it's going to be either a success or a failure. The other way is asynchronous execution, and that's often done through some other AWS components, such as trigger events from S3 or using eventbridge, which is a common pattern to invoke your Lambda, is you put an event on eventbridge, and it will then be processed by the Lambda. So that's just a couple boilerplate systems that you can build in AWS. At Norton, we actually have an event-driven application that we developed, which is using primarily eventbridge and Lambda. And in this application, we have events streaming from our monolithic backend. And we have downstream clients that are interested in those notifications. They want to know when user data has been changed or updated. And it's the job of this event-driven system to get those events to the user. So the advantages of this is it decouples the creation of the data and the modification of that from actually notifying the consumers. And this system is actually processing 20 million events a week. And just a little tidbit, that costs about $200 of AWS credits to do that. So it's actually a pretty cheap service if you have the right use case, being like short executions of your code. And another benefit of the event-driven system is it's passing off the responsibility of that message processing from one component to the next. So it's assuming that wherever you put it, whether it's EventBridge or Lambda, that event is safe, and whoever created the event can sleep well at night knowing that it will be processed successfully. That's a key component of the event-driven system. So to get production ready, we actually will have more than I just showed in that diagram. We're going to need to monitor our lambdas via logs, dashboards, and alarms. We're going to need to handle a few edge cases, such as retrying events in case of failures. We're going to need to write all of this system to be hosted as infrastructure as code, so you can spin it up or delete it really quickly. And finally, we're going to have a CI/CD pipeline. So a few more components of this Lambda ecosystem, event-driven ecosystem, are these other AWS components, such as SQS, CloudWatch, EventBus, and SNS. There's a couple others that you can add in, but this is basically all you need for the event bus, and you just need to link these components together, which is pretty easy to do in AWS. So I want to talk about a few edge cases that we encountered and how we addressed those. So one thing that was pretty clear that was Lambda's built-in retry functionality was limited, and it wouldn't work for our use case because we wanted to retry events for up to 24 hours. And more than the allotted 2 times that Lambda will retry if the event fails processing. And since this is the event-driven system where we're notifying external clients and making a lot of API calls, any one of those downstream clients could be down for any amount of time, and we need to process the event in that case by retrying it. So this is a sample of how that flow works. Is when an event fails in Lambda, the code will put it on SQS, and SQS will be the entry point for our retry system. A separate retry Lambda with specialized code will pull that message off of SQS and feed it back into the beginning of the loop, which is EventBus. And the loop cycle continues for up to 24 hours, until which case we just stop retrying that, and it gets put on a DLQ, which is basically going to persist for another couple weeks while the team can either look into that issue further or redrive the DLQ. So another edge case that you may run into when you're working in a production system is basically overloading clients with too much data. So in the example I'm showing, there's a producer and a consumer of events, and the producer might have a lot more throughput than the consumer. So in that case, you want to actually limit how fast you send messages to the consumer in order to prevent any downstream outages and also not get rate limited. A side effect of the asynchronous invocation of Lambda is actually an internal event queue. And this is completely managed by Lambda service, where when you invoke from EventBus, it has an internal message queue, and you can limit the number of Lambda functions that you auto-scale to. So instead of scaling to 1,000 or 1,000,000 Lambda functions, you might want to limit that to 5 to 10. And the byproduct of this is something called backpressure, which is this is a really good way to implement backpressure in my experience, because it's managed by Lambda, which makes it simple. So another edge case that you might encounter with AWS systems, whether it's an event-driven system like this or anything else, is an outage in AWS. So we've experienced entire regions going down for a couple hours, such as specifically for Lambda or EventBus. Each AWS service basically could go down at any time, even though it's pretty rare. And that's actually happened. So if one of the regions goes down, you want a way to automatically fail over to the other region. And using Event Bus, the way to do that is to use a global endpoint. And the global endpoint is part of the Event Bus service, but it's really a Route 53 DNS endpoint. So it's and it's based on some of the metrics that I mentioned earlier, the logs and the CloudWatch logs. And those logs are monitored to see the health of the data, to see if the service is operating. And if it finds that the service isn't operating, it assumes that the region is down and fails over automatically. And that can actually be, that's also been useful for production, as when we want to deploy some changes to production, we can fail over traffic to the secondary region, which will mean that we can test out those changes on a separate environment, and if there's any failures that we realize, we can switch back over to the primary one, which will be the stable environment that's been well tested. So this fault tolerance has those two benefits, the failover and also just basically A/B deployment. Yeah, so after we developed the code and handled the edge cases, you'll need a way to deploy all this, which is where the framework of Lambda comes into play. You need to build a framework around it by having Terraform code to easily create a new Lambda and deploy that. And another key aspect of getting ready for production is to have different environments. You'll need a develop environment, an int environment, and a production. And these all provide just different test beds for you to try out your new code. The way that we're testing, the big way we test is end-to-end tests. So you put in, that's basically putting in the data in the event bus and monitoring the logs to see if you have success or failures in different scenarios. So the steps of the specific steps that we have in our CI/CD pipeline is building the code, pushing the zip file to S3, and that zip file is what's used to create the Lambda. We then deploy all of the other AWS infra. We run automation tests, and we swap over to the new version of the Lambda. Excuse me. All right, and now that you've done all that, you're ready to push to prod. You can hit the big red button, and you're good to go. Thanks.